Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add wings and flight control surfaces to your physics-based helicopter. So within this physics series that I've been putting together, we've been pretty busy building out a lot of control systems to help move various types of vehicles through three-dimensional space using the Unreal Engine's physics system. And so after building out our wings and control surfaces for our fighter jet, I kind of wanted to circle back to our helicopter and give this a little bit more love. Since once we left it last, we created a gimbal thruster for our main rotor, and we're using a static thruster for our tail rotor. But if you've been kind of trying to fly it, it definitely takes a little bit of practice to fly this helicopter, and it's very, very unforgiving, especially when it comes to its pitch angle. And also, as we're kind of flying it through space, it has a tendency to want to get some side speed as well as forward speed. And really, when we're looking at helicopters in real life, they have a tendency to kind of straighten themselves out as they get faster. So we're going to go ahead and implement the missing control systems here as far as the tail elevator plane. As you can see, that big elevator in the back of the helicopter, but there's also a fin stabilizer as well. As you can see, back near the back there's a tapered section, and that's there to help kind of straighten the helicopter out during forward flight. So hopefully this should make our helicopter a lot easier to manage. It'll also make our flights a lot more stable, and it'll also make it a lot easier to recover from steep angles of decline, where, as you can see right there, we crashed our helicopter after we pitched past at least 18 degrees pitch. So we should be able to fix all of that, and it'll definitely make our helicopter a lot better to manage and fly, especially for someone who's just jumping in for the first time. So I'm just going to go ahead and put my controller off to one side, and we'll come back to the helicopter. So again, what we're going to do is we're going to get this tail elevator, and we'll get this horizontal fin. So let's get started. So to do that, I'm just going to go and open up the our Black Hawk helicopter blueprint. And for this demo, I went ahead and turned off the rotor blades. I did that because it was just kind of causing some lag and delay in my screen capture. So by turning it off, hopefully we'll create a much better video, a much higher video quality for you guys as we kind of add these new little control surfaces into our helicopter. But that's all I did. I just went and disconnected the event tick, but you can go ahead and keep that hooked up, and we'll be able to kind of make this helicopter fly a lot better. So the first control surface I want to do is going to be the elevator, and so to do that, I'm going to use the control surface configurations here so that we can create an elevator with variable pitch. So I'm going to create this. I'm going to make it an elevator. I'm going to negate the direction. And by negating the direction, it'll allow me to sync this with the prop pitch that we're doing on the main rotor. We need to give this a location, so I'm going to put this location on the rear elevator joint, so it's there. And again, because this animation, or this skeletal mesh was created more for cinematic animations versus physics movement, I'm just going to go ahead and just negate that root bone, which is right there. And then as far as area, I'm going to make this 6. So that's the surface area. Camera's going to stay 0, and I'm going to bring this max control angle to 10. I found that in testing that worked well for me. So I'm just going to go ahead, compile and save. And before I get started, I kind of want to talk a little bit more about our helicopter. So as I was kind of working this out, I definitely feel more and more that the center of gravity here, which is our center of gravity joint, should be more in line with the top of the helicopter engine bay, or at the bottom of the helicopter engine bay, or the top of the crew compartment. And a lot of that is what we really would like is this center joint to be perpendicular to our elevator joint. And if it was perpendicular to the elevator joint, then we wouldn't. I could probably use less movement angle on the blade on this elevator when working with it, and it will right now have a little bit of a positive pitch angle when we start picking up speed in level flight. But again, we're trying to simulate this out, and as always, I've got to work with what I got. And as you can see, again, we've got this root bone. Ideally, if we were making this for physics movement, and if you have access to the animator, we don't need this root bone here. So again, because this center of gravity joint, that's the joint that we want to connect to the physics particle as we kind of add these physics forces and move our vehicle through space. All right, so enough of that. Let's get back over to the helicopter. I'm just going to do one last check. Elevator negated, joint, take out the root bone. Area 6, so that's 3 on each side. And this is a max control angle of 10, which means it's positive 10 and negative 10. So the full range of motion would be 20 degrees. No lift multiplier, no drag multiplier. And I think we're good. So again, just compile it, save it. Again, I have the animations turned off to improve the video quality. So let's go ahead and test this using a tail plane. All right, so we've got our helicopter back. Let's go ahead and increase the speed. So if you kind of notice the data, so I've got the flight data here. And the first thing I'm noticing is definitely it's a lot more stable in my pitch angle. But also, I don't need as much, as I'm starting to make forward speed, I don't need as much power to my main rotor. And that's because in order for me to get more speed, I can give it more pitch angle. But the tail plane is actually trying to straighten the helicopter out. And because the tail plane's trying to straighten the helicopter out and I'm giving it more pitch angle, we're actually getting more efficiency out of our gimbal system. So that thrust vector. So and by doing so we can actually get a lot more speed. So let's go and turn this helicopter around and lift for less thrust on the main rotor. So as you can see, we're getting a lot more speed, with a lot less pitch angle in the cabin of the helicopter. So our level speed, our right speed, again, we still got that we can that right speed that we need to kind of fix. But as you can see, our helicopter is a lot more responsive. We can slow down a lot better by just pitching up a little bit. The tail plane makes things move a lot better. And also, because of having this tail plane in here, I'm just going to go ahead, bring it up. We can now pitch the helicopter a lot more aggressively, right? And that tail is going to help us keep control of the helicopter and help to bring us back out of those more aggressive pitch angles. So now our helicopter, it doesn't feel quite so unstable when we start pushing more aggressive pitch angles on the main blade. Thanks to that elevator system that we've just put in. Alright, so now that we've got the pitch under control and we've improved the pitch, we've improved the thrust of the helicopter, let's go ahead and add in our tail fin to help help the helicopter be a bit more straight and stable in forward flight. So I'm just going to go ahead and just pitch it back and stop everything. Let's go ahead and bring the blueprint back. So for doing the for that little horizontal fin, I'm going to use the foil configuration, and we're just going to create a new foil configuration. And instead of vertical, I'm going to use horizontal for a fin. For a location, I'm actually going to keep it at the same location as the as the elevator plane. And again, I'm just going to go ahead and negate out the root bone. As for shape, I'm going to use 1.5. Camber of 0, since I want it to be even on both sides. And I'm going to give it a little bit more drag. So I'm going to put a drag multiplier of 2. So as we start to get some side speed, that drag multiplier will help to kind of give us a little extra turn. And this is going to help us create a unique characteristic of roll to yaw. So at high speeds, when our helicopter flies, when we start to roll, we should also start to see the helicopter turn gradually. But at low speeds, since there's not enough air really going over it, and the surface area is so small, we should still be able to kind of skid the helicopter left and skid it right using the roll. But then at high speeds, we should start to see more of a turning mechanism into that yaw from using this, this fall shape. All right, so I'm just going to go ahead and compile and save. Again, let's move this over. And let's bring back the Black Hawk. So now we've got both the elevator and the horizontal fin in play. So I'm just going to power it up. We're now taking off. We're pushing over. And if I just try and get a bit of side speed, right? If I keep the speed small and slow, our helicopter can move sideways. Gonna try, and there's a little bit of yaw in there, even though we're at very slow speeds. But now I'm just going to go ahead and see if we can get a bit of runway. So now I'm going to speed the helicopter up, and as you can, again, I'm not needing as much throttle in order to get more vertical flight. But as I kind of take the roll out of the helicopter, you can see that the right speed is that the back fin is actually helping to create more straight and level flight for our helicopter. So those right speeds are a lot smaller based on the roll angles that we've got. So, and as I kind of roll in on that helicopter, you can start to see the helicopter now turn left as well. So I'm not using the tail rotor to turn the helicopter. I'm actually just using the roll and the speed of the speed of the air passing the tail to help give us that roll to yaw maneuver. And there it is. And I can still use the tail rotor to kind of get more aggressive tail angle. The helicopter definitely feels a lot more stable. It's got probably a little too much positive pitch now. Again, I think that's just because the center of gravity joint is just a little too low in compared to where the tail rotor is. But yeah, this helicopter definitely feels a lot better to fly. It's a lot more forgiving in the controllers. We can certainly kind of slow things down. And it can get, it can certainly slow down and stop a lot better. Yeah, it definitely starts to feel a lot more like a helicopter. Just having those little flight control extras in the back of the helicopter. And again, as we kind of come down, because it's giving us a little extra lift in the back of the helicopter as we're coming down, it's a lot easier now to actually land our helicopter as well. So as I'm kind of taking the power off, we can actually come in and actually spot the landing pretty smoothly as well. So yeah, that was it. Again, I just wanted to kind of put that out there and kind of show what you can do with how all of these systems can work together as you're kind of building out your physics system. So a helicopter is not just all thrust; it does have some aerodynamic components as well that we can leverage to improve those characteristics within your vehicles as you're kind of building out your vehicle simulations. All right, so I'm going to just kind of call it here. So as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And if you have any questions, feel free to reach out in the comments section. I enjoy reading them, and if I've got some good ideas and solutions, I will get back to you as quickly as I can. And I always enjoy seeing what you guys are doing with the physics system. Okay, so I will see you again in the next video. Cheers. Bye.